In this video, I'm going to talk about two types of chemical reactions, synthesis and decomposition reactions. So remember, in all chemical reactions, mass is conserved. That means the mass that goes into the reaction in form of the reactants will be the same mass that comes out in the form of the products. Along with the mass, that means the number and kind of atoms that go in will be the same as the number and kinds of atoms that go out. Atoms are not created or destroyed in chemical reactions, but they are rearranged. Mass can be converted to energy in nuclear reactions, but that is not the subject of this video. There are 5 basic types of chemical reactions: synthesis, decomposition, single replacement, double replacement, and combustion. This video will just focus on those first 2 types. So a synthesis reaction, which you will also see referred to as a formation reaction or a combination reaction, a synthesis reaction occurs when 2 or more substances are combined to form something new. In a synthesis reaction, energy is usually released, which makes it an exothermic reaction. It will feel hot. If you use a thermometer, you'll be able to track the temperature, or if you're using your hands on a reaction that's in a beaker, you can feel the heat. So one type of synthesis reaction will take 2 distinct elements and put them together to form a compound. So the example here is if you take magnesium and ignite it in air, magnesium will react with the oxygen in the air and produce magnesium oxide. So 2 elements forming a compound. Another type of synthesis reaction is when an element reacts with a compound and makes a new compound. In your car, you have a catalytic converter, which is what this illustration is showing, where the carbon monoxide that is produced by the ignition of gasoline reacts with oxygen, again from the air, to produce carbon dioxide, which is not a great gas, but it is not as poisonous as carbon monoxide, and so it is healthier for all of us all around. And then you can have 2 compounds combining to make a more complex compound. So the example here is sulfur trioxide, which is a gas that is released by factory emissions, reacting with water in the atmosphere to produce sulfuric acid, H2SO4, which then can produce acid rain in an area with a lot of air pollution. Acid rain can be quite harmful to plants, as you see these forests that are suffering from many applications of slightly acidic water, and it also over time can break down marble statues. You can see the difference in the facial features on this one from 1908. You can see a face there to 1969. Really, all of the facial features have been eroded away by the acid rain falling on this statue. The opposite of a synthesis reaction is a decomposition reaction. And in a decomposition reaction, a compound is broken down into 2 or more simpler substances. Most decomposition reactions do require the input of energy. Energy needs to go in, and so that makes it an endothermic reaction, and it will feel cool to the touch, or a thermometer will show the temperature going down. In a decomposition reaction, the substances can turn into their original elements, or they can turn into smaller compounds. So here's an example of a compound that will turn into its own original elements. We have the compound mercury oxide here, and so this is, you can see in the test tube, it's an orange-brown colored solid, and giving a picture, you can see that it's containing both mercury and oxygen. The mercury is represented by these little blue balls, and the oxygen by sort of these reddish balls. If heat is applied, so here's energy going in to start this decomposition reaction. At the end of the reaction, you can see the pure mercury, silvery substance there in the bottom of the test tube. And of course, the oxygen, being a gas, is just going to leave out of the top of the test tube. Decomposition reactions, as I said, can also take a more complex compound and break them down into simpler compounds. So the example here is calcium carbonate, which is a white powder, solid, can be broken down again with the application of heat into calcium oxide, which is also white, and carbon dioxide gas. So experimental setup that would do this is being shown over here in this illustration where you apply heat to calcium carbonate. And then if you have a glass tube, you can then collect the calcium or the carbon dioxide in a test tube and test for its presence in various ways. So let's look at these reactions and predict the products. If we have a solid aluminum plus nitrogen gas, what's going to happen? Well, in this case, we have two elements, so it's going to form a compound. It will make aluminum nitride, and just incidentally, the charges on aluminum would be a +3, and the charge on nitrogen would be a -3. To balance this equation, we'd have to put some 2's in front here, coefficients. Is this a synthesis or decomposition reaction? Well, we made something new, so it's a synthesis reaction. With this second reaction, we're starting off with dinitrogen monoxide. And so it is a compound, and it will break down then into nitrogen, a diatomic element, so it'll be N2, and oxygen, another diatomic element, so another N2. So to balance this equation, we'll have to put, again, some coefficients here in front. And this is our decomposition reaction. So in general, synthesis and decomposition reactions are ones that are going to involve solids and or gases. They're not as likely to occur with anything in aqueous solution. So this is my overview of these first two types of chemical reactions, synthesis and decomposition.